Welcome to The Explainer. Today, we're diving into something that every single person working with data has to face: how to clean up a messy dataset using the power of Python and Pandas.
So let's start with a fact that might sound crazy, but if you've been in the trenches with data, you'll be nodding your head. A whopping 80% of a data scientist's job isn't the glamorous, headline-grabbing model building. Nope, it's the process of getting the data ready for it. It's tedious, it's tough, but this is where the real work happens. Okay, let's get into it.
All right, here's our game plan for this explainer. We'll start with the harsh reality of raw data. Then we'll get our hands dirty with the most common issues: gaps and duplicates. From there, we'll move on to standardizing everything before tackling the really tricky stuff like messy text and outliers. And finally, we'll see how it all comes together.
Okay, Section 1, the reality of raw data. You've definitely heard the phrase, garbage in, garbage out. And let me tell you, it is the #1 nightmare for anyone working with data. Because why is all this cleaning so important? Well, it's pretty simple. Your results are only ever as good as the data you start with.
You know, data in the real world almost never shows up in a nice, neat package. It's usually called dirty data for a reason. It's this minefield of missing values, bizarre formatting, and entries that just make absolutely no sense. If you try to build any kind of analyses on that foundation, well, your results are going to be unreliable at best and flat out wrong at worst.
So cleaning data isn't just about deleting stuff. It's more like being a sculptor. You're systematically transforming this messy block of marble into a high-quality, trustworthy asset. The end goal here is to build a foundation of trust, to get your data to a point where it's accurate, complete, and consistent. That is the only way you're going to get insights you can actually believe.
All right, Section 2. Let's open up the toolbox and start with the two biggest culprits you'll find in pretty much any data set: those annoying empty cells and all those duplicate records.
First up, duplicates. What in the world do you do when you have the same piece of information entered more than once? And trust me, this happens all the time.
Now, the real danger with duplicates is how sneaky they can be. Just look at this. John's email appears twice, but with tiny differences in his name and age. If you're trying to count unique customers, you'd accidentally count them twice. All of a sudden, your customer count is inflated and your average age is skewed. It's a disaster waiting to happen.
Fortunately, Pandas gives us a beautifully simple solution. It's this powerful little command, drop duplicates. And we can be really precise with it. We're telling it, hey, just focus on the email column to figure out what's a duplicate. And that keep equals last part, that's us telling it to hold on to the most recent entry for that customer. It's so clean.
And boom, just like that, the duplicate record for John is gone. We're left with a clean, trustworthy list of unique customers. Okay, now that we've handled the duplicates, what about all those pesky, empty values?
When it comes to missing data, you'll usually see it as NaN, which just means not a number. We have a few strategies. Option 1, just drop the rows entirely. This can work if your data set is huge and losing a few records isn't a big deal. Option 2, and this is often better, is to fill the gap with a smart value, like the average or the median. And a really cool third option, especially for time series data, is to interpolate. Basically make an educated guess based on the numbers around it. The key is, the right choice always depends on your specific situation.
So check this out in action. Instead of just deleting John's record because his age is missing, we can fill it in. We'll use the median age of the whole dataset. And for Jane's missing income, we can pop in the average income. Just like that, our data is complete, and we didn't have to throw away any valuable information.
Okay, our data is now free of duplicates and gaps. Awesome. The next big step is to fix all the inconsistencies. We need to get every column into the right format so our data is speaking one consistent language. This is such a classic problem. You look at one column and see names in lowercase, some in all caps, and the dates are a total free-for-all. But with a couple of simple Pandas functions, we can fix this instantly. We can standardize every name to a nice, clean title case and convert all those wacky date formats into a single, uniform format that a machine can actually work with.
And here's a little pro tip for you. This is a real game changer.
If you have a column with just a few repeating values, think department or status, you can convert it to a special category data type. This one move can dramatically save on memory and speed up your operations. It's a huge efficiency win.
Okay, section 4, now we're getting into the really tricky stuff. We're going to talk about how to clean up complex, messy text and how to handle those impossible values we call outliers.
For cleaning really complex text, we need a secret weapon. It's called regular expressions, or just regex for short. The best way to think about it is like a find and replace tool, but on steroids. It allows you to search for and change complex patterns in text, not just simple words.
A perfect example? Phone numbers. They come in with parentheses, dashes, all sorts of junk. But with one little line of regex, we can tell the computer, hey, find anything that isn't a digit and just remove it. And just like that, every phone number is clean and uniform.
So that's text. But what about data that is just impossible? Like an age of 123. These are outliers. They're values so far outside the normal range that you can be pretty certain they're just errors.
You can see the problem right here. Mike's age is 123? Not likely. And Jane made 2,000 purchases? That seems pretty suspicious. If we leave these values in, they're going to completely throw off any calculations we try to make, like finding the average age or average number of purchases.
So the solution is actually pretty logical. We just need to define what's reasonable. With this simple line of code, we're basically telling Pandas, look, I only want to keep the rows where the age is between 18 and 100. It's a simple filter that just kicks out anything that falls outside the realm of possibility.
And that brings us to our final section, from messy to mastered. We have come a long way. We've dealt with duplicates, filled in the gaps, standardized our formats, and weeded out the outliers. Let's just take a moment to recap this whole journey. The most important thing to remember is that data cleaning isn't a single task you check off a list. It's a cycle. You import, you fix, you standardize, you verify, and sometimes you have to loop right back to the beginning. It's this continuous process of refinement that transforms that messy, raw data into a reliable asset that can actually give you trustworthy results.
So we've gone from a chaotic, untrustworthy mess to a clean, structured data set that's ready for some serious analysis. The final question is no longer about the quality of your data. The question is now about the powerful insights, the hidden stories that you are finally equipped to uncover.